go over some rate modeling problems. So hopefully you guys have had a chance to try these, at least just try whatever parts you could figure out based off the notes and example we did yesterday. So rate models are really just kind of like applications of the fundamental theorem of calculus part one. The amount of something now is equal to what it was at some other known time, plus the accumulation of all the changes to it, which is the integral of the derivative. Now, in these rate models, usually there's two derivatives, which is kind of a new thing. There's an incoming derivative, positive derivative, and an outgoing one, a negative one. So I like to a lot of times think of them as entering and leaving. So we're going to do a few of these. You're going to start to see some similarities of common types of questions, but this is kind of based off an idea that we've already learned this year, but being applied to word problems. So your answers generally need to have units. Sometimes you have to explain a little more about what your answer means. So the rate at which people enter an amusement park. So this is entering. So this is addition. I like to emphasize which one's being added, which one's being subtracted, because the one that's being taken away won't have a negative usually. The rate at which people leave is that. These are all going to be graphing calculator problems today. So what I usually do, take advantage of my graphing calculator, is enter these into the Y menu, because I know I'm going to be doing multiple calculations with both of these, sometimes both at the same time, sometimes one or the other. And it's going to be very convenient and quick to just do vars, y vars, y1, or vars, y vars, y2. Not even necessarily going to graph these, but let's go ahead and enter these in 15,600. The other thing about speeding, besides the benefit of speeding up your work, it also allows you to just enter these one time and just be extra careful to enter them in correctly, because if you enter in wrong, you're going to lose points because you're going to get the wrong answer. So make sure you have all the right grouping symbols, double, triple check it. Even if we can do these by hand, you're going to want to use your calculator because it's way faster than you, and it generally makes less mistakes than you do as long as you tell it to do the right thing. So that's the first thing to do. Make sure you're in radio mode all the time on the AP calculus test. So we got those entered. I'm not going to graph them unless I really need to. Graphing, could be cool, but it takes time, and I think we can get away usually without any graphs. So both ET and LT are measured in people per hour. So those are going to be units, hours for time, people for the amount. T is measured in hours after midnight. So that T equals 0 at midnight. The functions are valid from 9 to 23, the hours during which the park is open. So these only make sense when the park's open, because otherwise you're going to have people entering and leaving when the park is closed. At T equals 9, there are no people in the park, which is when it opens, which kind of makes sense. So that's your initial condition. A9 equals 0. Generally, you're given an initial condition on these rate models, and you're going to need that for sure. How many people entered the park by 5 p.m., which is T equals 17? Round your answer to the nearest whole number. Now, generally, we always do 3 decimal accuracy for all answers in the AP test, round or truncated. Even if it's people like, oh, there can't be a fraction of people. Well, okay, but maybe this time we're going to give whole people. Nearest whole number. So you're going to round down or round up. You're going to round to the nearest whole number when you're done. So let's try and write a rate model down. Usually we're not going to use it right away. Might not even use it till like part C or something. But I like to just write it down because it's sort of what this whole idea is based off. So the amount of people, I like to use capital A for amount unless they tell me something else. The amount of people is going to be equal to the amount of people at some earlier known time, which is at time 9. There are 0 people, plus the accumulation of all the people that have entered. But it starts at 9 to some time, and it's the entering rate. We could just write ET dt right here. Minus the people who've left from 9. So it's not 0 to T, which we often do. Time 0 often is initial condition. That'd be at midnight. Wouldn't make sense. They said this is only valid at 9. It starts at 9. That's your initial condition. So that's what the bottom limit needs to be. LT dt. So this is our rate model. Okay. Sort of the basic big idea here. Now, we're going to often use parts of it or just do different things. It says how many people entered. It doesn't say how many people are in the park. If you plugged, 5 p.m. 17 hour 17, you got to convert p.m. to 24 hours. If you plug that in, that'd give you the amount of people in the park at 5 p.m. It just said how many people have entered the park by 5 p.m. So that's just this entering part. Now you got to write this down. This is called the setup. If you don't write this down, even if you get the right answer, you're going to lose points. The point breakdown, by the way, this is at 9 points total, all free response questions. And part A is 3 points. Part B is 1 point, which probably means it's something weird. Part C is 3 points. Part D is 2 points. The more points, generally, the more kind of normal questions. Maybe not as hard to figure out. And this is a very straightforward. That's your setup. This is worth, let's see, how many people? This is worth 2 points. So they might say 1 point for the limits and 1 point for the integrand, which is the stuff that's inside the integral, and then 1 point for the answer. So even if you don't get the answer, even if you run out of time with your calculator, you're still allowed to work on your calculator questions. Your calculator's just gone away. You can get 2 out of 3 points. So we're going to go math 9, and I know I stored this in y1 vars, y vars function, y1, comma x, comma 9, comma 17. You don't need to type any of this. You don't need to write any of this stuff down. You don't got to tell them what program you used or whatever. So this is 6004.270324. I don't know. Just in case I have to use this for something else, I like to sometimes write a few extra decimals, because if you're going to use this in some other work, you need to carry extra decimals. But we could write our answer kind of, let's see, how many people in the 6,004 people entered the park by 5 p.m. I mean, that's a nice thorough answer, includes units, includes context of the problem. All right, so that's 3 points. The answer is 1 point. Now, if you didn't round to the nearest whole person, you lose that whole point. There's no half points. So pay attention. You might notice I circled that. I made a big deal about it because it's kind of different than normal. Otherwise, I'm giving 3 decimal actually. Just regardless of what my logic tells me, what seems like a good answer. The price of admission is $15 until 5 p.m. After 5 p.m., it's $11, so you get a little discount if you go late. How many dollars are collected from the admissions to the park on the given day? Round your answer to the nearest whole number, which is going to be dollars. So we got it now. This only has to do with people entering, right? So if you integrate the entering rate, that gives you how many people entered. So we could say, all right, well, from up until 5 p.m., we charge $15. So we can multiply that by 15, and then $11 for 17 until now. We got to make sense. When does the park close? 23. And that's the entering rate also. So this is the setup. So we could do this all on your calculator at once. And in fact, we already got the answer for the first part. So we could say times 15. So that's that part, plus 11 times math 9 vars y vars function y1 comma x comma 17 comma 23. And there you go. It's 104,048.1652. Now, it would make sense to go ahead and potentially get cents of a dollar, except that they don't actually charge anyone a fraction of a dollar. So we're going to say our answer is in dollars, units, 104,048 was collected from admissions to the park on the given day. So that's a nice thorough answer with units and all that stuff. Okay. So yeah, that was kind of a weird question. You're like talking about trying to figure out how much money you made, and it's not like a everyday kind of calculus question. Part A was a lot more kind of normal. C says let ht equal the integral from 9 to t ex minus lx for 9 to 23. The value of h17 to the nearest whole number is 3725. Find the value of h prime 17 and explain the meaning of h17 and h prime 17 in the context of the amusement park. Okay. Now, they give us this ht 9 to t e x minus lx dx. Now, the reason I put x's here is because there's a t as a limit, so technically that's a little more proper because they're essentially this is a rate model. They just wrote the rate model. They called it h, so a, and the first term drops out. That's why there's no number in front. And they combine these in the same integral, which we could always do because they generally have the same limits. So from this, h17, which we can just calculate on our calculator. So we could do math 9, vars, y vars function, y1, minus vars, y vars function, y2, right? That's et minus lt, comma x, comma 9, comma 17. I guess we could write that down too. And it's going to give us an answer. So we could write this. Okay, 9 to 17 of ex minus lx dx. And it equals 3725.162916. Okay, so maybe a point just for calculating that. By the way, in the last part, last part was only worth 1 point. So this is 3 points, 1 point. This one is 3 points. So now we haven't gained a point yet, but we have to explain what this means in the context of the problem. So, and it says the value of h17 nearest whole number is 3720. Oh, shoot. They actually found h17 for us. So I guess we just did the work again and got 3725, the nearest whole number. Now, what is that? Well, that's what our rate model is. Our rate model is telling you how much of something is there at that given time. This is the amount of people in the park at time 17 or 5 p.m. So we'd say there are 3725. What are the units? People in the park at t equals 17 hours. You got to put units, or 5 p.m. I'm assuming both of those would be fine. That's point. So you got to recognize, oh yeah, this is a rate model. That's the whole rate model. Okay. Now I said to find h prime. Now what's h prime of t? H prime of t is going to equal et minus lt, because fundamental theorem of calculus part 2 says if you take a derivative integral, they undo each other. You got to plug limits in, top first, and then multiply by the derivative limit, which would be 1. Plug the bottom limits in, 9. Multiply the derivative of what you plugged in, 0, 0. They all drop out. You get et minus lt, which makes sense that the derivative of the amount of people in the park should equal the derivative of the amount of people coming in minus the derivative of people coming out. And that's kind of giving you an idea of what you're trying to do. Okay. So we can plug this in, and this is just good setup. Okay, they said to find it. So I'm going to write that. Now, I could, because I entered these equations in the Y menu, one way I can do quick calculations is go to the table, which is second graph button. There might be some values in here from before. So you could type in 17, and it gives you 380.487804 minus 760.769230. And then I could go ahead and find the difference of that on home screen. 380.487804 minus 760.76930. And we get negative 380.281 round or truncate. Now, did they tell you to round or truncate or round to the nearest whole number for h prime? No. And this is a rate, so it kind of makes sense that maybe be appropriate to go ahead. Now, what are the units of this? The units of this is the derivative. H is the amount of people in the park. The derivative is with respect to time, so it's amount of people. It's people per change in time, which is hours. It's people per hour. And now we need to explain what this means. Now, we could just say it's the derivative of the amount of people in the park. I don't think that's quite what they're getting at. Usually, if they say to explain a rate in the context of the problem, one of the big things you want to do is if it's negative, you want to say that something is decreasing. Or if it's positive, you want to say that something is increasing. So I would say the best interpretation is the number of people in the park at 5 p.m. You want to be specific about the time, okay? Mention the time at 5 p.m. is decreasing at a rate of negative 380 point. I don't think they said nearest whole number anywhere, so I'm going to go ahead and go through decimal accuracy. 281 people per hour. Now, here's the deal. I said decreasing, so you got to be careful here. Don't want to put the negative, because if you're decreasing a negative rate, that means you're actually increasing, because this is a double negative. So you want to put the word decreasing, but then you don't want to put the negative. The negative tells you it is decreasing, but then the word decreasing already indicates a negative, so don't put another negative, because that's not quite right. So that was a point. It was a point for calculating. It was a point for explaining the first one, which they actually gave us, but I calculated it, and a point for explaining that. This is part C is very common for rate models. They say, hey, find the rate and tell us what that means in the context of the problem. It usually means something's increasing, decreasing, use the units, be specific. That's very common. D, super common. At what time between 9 and 23, which is the park's opening hours, does the model predict that the number of people in the park is an absolute max? So we're looking for max amount of people, or max H, if you want to go with the name they gave it on part C. This is an EVT problem. You want to do extreme value theorem because you got to justify your answer, and anything other than extreme value theorem is going to be hard to justify if it even gives you an answer. So hopefully we can use extreme value theorem. We have endpoints, so we have a closed interval. It needs to be a continuous function, and we got to find critical points. So these are your endpoints. Might be good to write that. And we got to find critical points. So I'm going to write all this stuff down. I'm not going to abbreviate things. I'm trying to be very thorough. How do you find critical points? Well, you take A prime or H prime, and it equals ET minus LT. Okay, now that's not good enough. That's a derivative. Equals 0 or undefined. You got to write this. You could lose points for not writing that. But you could get a point just for writing that sometimes on this kind of thing. But you want to write that. Now, we want to find those times. Now, that's when these two curves intersect each other, which you could graph them. Maybe you chose to graph them and find the intersections. But I find it easier to put them all in one equation equal to 0 and find the x-intercepts. Now, I've already entered these. So instead of re-entering them, I'm going to do vars, y-vars function, y1, minus vars, y-vars function, y2. So I'm actually going to put a new graph in there referring to those. I'm going to turn those off because I don't want to see their graph. Now, if I turn them off, this third one still works. So I'm just going to graph this one. I'm going to go to window. I always go to window before graph. And I say, well, what are the endpoints I'm looking at? Well, 9 to 23 is where we're looking for critical points. And we're just looking for the x-intercepts of this graph. So I just set y min to -1, y max to 1, just so you can have a nice close-up view of the x-axis. And I graph it. Now, we might get more than one answer. You got to list them all. So there's one. And that's it. So we got to find it. So second, trace calculate 0, because it's x-intercept. And this was, right, 9, 10, 11, 12, 13, 14, 15. It looks like it's around 16. I'm going to say 15 to 17. Guess 16. And we want to write more than 3 decimals right now. 15.794815, because we're going to use this in another calculation. So do not round or truncate to 3 decimals in the middle of your work, because it'll throw off the third decimal of your accuracy for final answer, potentially. So we got our critical point, we got our endpoints. So now we're going to make a table, and just to organize our information, and we're going to plug them into our rate model, which you call AT or HT, and that's the thing that we wrote at the beginning. A9, which is 0, plus 9 to t et dt minus 9 to t lt dt. Or you could put them in the same integral like they showed you guys on part C. And then we're going to put 9, and then we're going to put 15.794815. And we're going to put 23. Don't be like, oh, I'm only going to write 3, but I'm going to calculate more. Whatever you can put in your calculator, write it down, okay? Because your work should match what's on your paper. Now I'm going to go back to Y and turn these back on, because I'm going to use them for some calculations, and just get rid of this one. Because I'm going to do these whole calculations in my calculator. Now, 9 is 0 people, right? Because that's the initial condition they give you. If you plug 9, you integrate 9 to 9, 9 to 9, 0, 0. And then I'm going to plug these other values in here. So the way we do it is we go math 9, and we can do these as 2 separate integrals or together. It's up to you. Vars, y vars, function, y1, make sure you're doing the correct one, comma x, comma 0, comma 15.794815 minus math 9, vars, y vars, function y2, comma x, comma, 9, comma 15.794815. Now, I made a mistake up here. I put 0 just because I'm so used to it. It's supposed to be 9 because I'm plugging into this, right? Okay. Hit enter. And that should give us this value right here. 3950.68062. I'm just going to write a few extra decimals. Okay, we're going to do it again. Now, I don't want to retype all that stuff, so I'm going to do second enter, and it copies it. And I'm going to do 23, and then delete the extra numbers. And then here, 23, delete. Okay, hit enter. So we got to check the endpoints and the critical points. And that's what extreme value theorem tells you to do. 1.0138579. Now it's kind of interesting that when the part closes, there's like one person in there. Like straggler, someone hiding out or something. Okay, now we have everything we need to write our answer. We're looking for the max. So that's right here. This is the max. Let's write it in a very nice, detailed way and justify our answer. This is worth 3 points, and your justification is probably going to be 1 point. And you should probably put units. So we're going to say, I'm going to try and rewrite it. The number of people in the park is a maximum of 3950. Now, did they say it round to the nearest whole number? I mean, maybe it'd be fine. I'm assuming, I don't know, maybe I don't know. It's a little sketchy here. People, number of people, maximum of, I already said people, so maybe I don't need to say people, at time t equals 15.794 hours, or 5 if you round up, units. Mention time. You don't necessarily need to change that back to 24-hour time. I wouldn't change it to hours and minutes. Okay, now that's the answer. By extreme value theorem, write it out. Don't write EVT. Extreme value theorem. You want this best extreme value theorem. Now, naming the theorem isn't enough usually. You should name it, but then you need name. Well, how does the theorem work? By checking endpoints and critical points. Points on this were 1 point for actually writing that down, 1 point for finding your critical point, and 1 point for the answer. So if you didn't write that down, you lost that point. Even if you got the right critical point, did all the rest of the work. So, all right. Wow. I spent 26 minutes on that. It's going to be a long video. But feel free to go ahead if you want. Okay. The more of these you do, the better you're going to get them. And you should expect one on your first practice test this week. Generally, one free response problem on your out of your 6 on your AP test will probably involve a rate model. And they show up on multiple choice questions too. Just not as crazy. Maybe just like one question about it. The amount of water in a storage tank in gallons is modeled by a continuous function of the time interval, where t is measured in hours. In this model, rates are given as follows. The rate at which water enters the tank is this, from 0 to 7. The rate of water leaves the tank is this piecewise graph. The graphs of F and G, which intersect at these numbers, are shown in the figure above. At time t equals 0, the amount of water in the tank is 5,000 gallons. So this is your initial condition. So you want to read through all this and say, okay, what are all the things I got? I got my initial condition. And they actually give you a graph right here. And so this is the sine curve. This is the entering rate. And this piecewise one is the leaving rate. Okay. And then they give you these intersections, so you don't have to find them. We could find them because we have a graphing calculator if we wanted. This one's 1.617 and this one's 5.076. Looks like 2,000. Those are just the times, right? The y value would be 250. You probably just need the times. Those are gonna be critical points. Those are gonna be potential absolute maxes, mins. Let's try and write the rate model down. The amount of water in the tank equals the amount at time 0 they gave us was 5,000 plus the integral of what's entering ft dt from 0 to t minus what's leaving gt dt. Okay, that's our rate model. And we're going to probably for sure use it at some point. Probably going to use a lot of parts of it, do different things to it, take a derivative, get rates. Part A says, how many gallons of water enter the tank from 0 to 7? Round your answer to the nearest gallon. If you don't round it to the nearest gallon, you give me 3 decimal accuracy because I've trained you so well, you're going to lose a whole point. The breakdown of points on this problem are 2 points, 2 points, 5 points. Adds up to 9 points. So this is 2 points. So we just want what's entered. So that's from 0 to 7, right? So it's 0 to 7 of ft dt. You don't need to write the whole equation in there, but you can use the name they gave it. But you need to write that. That's your setup. That's 1 point right there. And if you don't write it, you don't get the point, even if you get the right answer. So you got to show your setups. Now I'm going to do what I've done on other problems. I'm going to go into the y menu and I'm going to enter these equations so I don't have to do them again. 100x squared, we put x's to the t's, sine square root of x, close. Make sure you're in radian mode. This one's a little harder. I don't know if I'm going to do this one. 250 and 2000. I mean, I could probably just type those in. The reason I'm putting these in here is not to make a graph, and I could recreate this graph and find those intersection points myself, but it's so I don't have to type these in every time on the math screen when I want to do work. Like right here, I'm going to do math 9, and I'm going to do vars, y vars function y1. You got to make sure where you typed in, that's entering rate, comma x, comma 0, comma 7. And that's a lot faster. I typed in one time really well, so I don't have to bother with it a bunch of times. I'm going to write my answer down, 8263.806543. I'm just writing those down just in case I need this for something else, even though it's just round to the nearest gallons, nearest gallon. So how many gallons of water in the tank? 8264 gallons of water entered the tank during the time interval 0 to 7 hours. It's a nice, thorough answer. Units, context. B, from 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. Give a reason for your answer. Now, decreasing means getting less and less, negative change, negative rate, negative derivative. So we're looking for where it's a negative derivative. Now, we could look at the picture, I think, and figure that out. It's going to be when the water's decreasing is when the leaving rate is more than the entering rate. And so this is here, this chunk, and this chunk. So we can look at our picture. They already gave us the values, and we could write it down. And we could say the reason is that the leaving rate is more than the entering rate, or the overall derivative is negative. So let's see. Let's write down the answer. The amount of water in the tank is decreasing on the intervals, so the chunks intervals. Now we're going to say 0 and include 0, they said, to 1.617 hours and 3, but not including 3, or I don't know, because it's open dot. So I don't know, it's a little iffy. And we talked about increasing, decreasing. Do we include the endpoints? And in this case, yeah, I think we generally do, but 5.076 hours. And the reason is since the entering rate FT is less than the leaving rate GT, so this is kind of a short way of showing that for the similar intervals. So I would say 0 to 1.617. Now, FT is not less than GT at 1.67. They're actually equal. So even though I say it's decreasing there because we include the endpoints, I don't say it's less than there. And 3 to 5.076. And again, I don't include 5.076. I include it for where it's decreasing because we include endpoints, but I don't include it for saying that F is less than G because they're equal. So another way of saying it is that F of T minus G of T is negative. I mean, you could say that also. So yeah, it might be a couple different ways of doing that. Now, as we're 2 points, and 1 point was the name of the intervals. and 1 point was for your explanation. Okay. Now, part C is 5 points. 0 to t, at what time t is the amount of water in the tank the greatest? To the nearest gallon. Compute the amount of water at this time, justify your answer. So they're saying what time and tell us how much. So I always answer my absolute maxes mins with the amount and the location, just because sometimes I ask for the amount, sometimes I ask for the location, sometimes I ask for both. And in any of those situations, I'm covered. So I hope I've been telling you guys to do that since chapter 1. So hopefully you guys don't even think twice about it. Justify your answer. It means name the theorem, name how it works, show all the work that goes to it. So 0 to 7 are our endpoints, which is one of the things you need to identify. And we're looking for an absolute max amount. Now, the interesting thing is we haven't even used our whole rate model yet. So we get to do that now. So now we got to find critical points. So I would write it out. Critical points. I wouldn't abbreviate it. I wouldn't do CP. This is free response. Unless if it's multiple choice, be lazy. But how do you find critical points? This is the calculus. You take the derivative of the amount. I mean, we could rewrite our rate model here so they know what we're talking about when we write A prime T. Okay, so A prime is derivative 5,000, 0. Derivative this, fundamental theorem of calculus part 2, we're going to get FT minus GT. And we're going to set it equal to 0 undefined. Write that down. Write equals 0 undefined. Label your work. Don't just write FT minus GT. Don't set it equals 0. Okay, so then we're going to find the times. Now, we could graph these two equations separately and find their intersection, which we already did. Oh, let's just, okay. We already know the answers to this. This is, I mean, if you want, I don't even think you need to write this, but you can say, okay, well, this is when FT equals GT. Or it's undefined, which I think it's going to be undefined at 3. Look at your graph up here. At 3, it's undefined. I think that's a point that a lot of people are going to miss. They're going to find the intersections, but they're going to skip 3. But 3 is where it's undefined. So our critical points are 1.617, 3, and 5.076. Those are our critical points. I can see a lot of people missing 3 because that would be where it's undefined. Because F minus G doesn't equal anything because G isn't even defined at 3, right? If you look at the piecewise function, G doesn't have a value at 3. So how would F minus G, what would that equal if G is not defined? So don't miss 3. So now we're going to make a table. And this one's going to get a little interesting. So we're doing our rate model. And I'm writing it kind of generically right now. And we're going to put our endpoints in 0, 1.617, 3, 5.076, 7. Now, usually I would make sure I had more than 3 decimals in my work, but they just gave us those numbers. So I'm assuming that's okay. We could find a more accurate version of the answers if we solve this on our calculator, which we could. Here, I'll show you real quick. Wait, well, yeah, I don't know. So if you plug 0 in here, you get 5,000. That one's easy. Now you got to be careful because G is a piecewise function. So when we do this one, it's going to be to 1.67, which is when G is 250. So I think I'm going to kind of manually put this in. So I'm going to say 5,000 plus math 9 vars, y vars, function y1, y1, comma, x, comma, 0, comma, 1.617, minus math 9, And instead of vars, y vars, I'm just going to type it in. It's 250, comma x, comma 0, comma 1.617. So $4719.2222805. Okay, we're going to do the same thing again. I'm going to go ahead and do the 5.0 just because it has all the decimals in it. Well, no. I'm going to do 3. So 3 uses the same g function. So we're still on 250. If you look at the graph, g is still 250 from 0 to 3. And wait for the answer. 5126.5908. Okay. Now this gets interesting because now we want to do it all the way to 5.076. So we're going to say 5 second enter gives you insert 0.076. But here's the deal. We're not going to say this one is 0 to 5.076 because the function is only 250 from 0 to 3. So we're going to actually leave that one there and then subtract another one, math 9. And we're going to do the next one is supposed to be 2000 is the leaving rate, comma x, comma, and we're going to start at 3 and go to 5.076. So that's kind of tricky because you have to break up the integral for g because it's piecewise. You got to go 0 to 3 of 250 and then 3 to numbers after 3 of 2000. I can CPU messing that up. So that's 4016.880955. And then I'm going to do second enter, and we're going to do it again with 7. So we're going to go 7 on the entering rate the whole time. It's the same. 0 to 3 for 250. Leave that there. And then 3 to 7 for the 2000 rate. So that's 4513.806543. Okay, so we got a lot of good work here to support our answer. We were looking for the max, and so the max looks like it's right there. And even if you found the max, but you didn't calculate the critical points and the endpoints, you would lose points because you're not doing. So let's write the answer very thoroughly because this time they actually asked for everything. The amount of water is in the tank is the greatest 5120, and I think they said round to the nearest gallon, 5127 gallons of water at time t equals 3 hours. Okay, so that's the answer. By extreme value theorem. Okay, how does that work? Checking endpoints and critical points. This is how I'd write my answer every time anyways. Okay, so 5 points. They gave you 1 point for getting the critical points right. So if you missed 3, you lost that point. They gave you 1 point for calculating 3, by the way, which ended up being your max. So it would stink if you missed it. They gave you 1 point for calculating 7. And so that's 4 points. They gave you 1 point for the answer and justification. And then I don't know where the other point was, but But that's extreme value theorem. We've been doing extreme value theorem for a while. Okay, cool. I did that one a little faster than the last one. That was only 19 minutes, so 26. Now, you get about 15 minutes per problem here when you're on the AP test, so you got to be working. Okay, here's another good classic rate model problem. And we're allowed to use a calculator on this. So let's see. It says there's snow on Janet's driveway. When there is snow on Janet's driveway, when snow begins to fall at midnight. Or maybe there is it means there's no snow? Maybe no snow? I don't know. Maybe I typed that wrong. From midnight to 9 a.m., snow accumulates in the driveway at a rate modeled by this. So that's the arriving rate of snow, and we're not losing any snow. Cubic feet per hour, those are units. Volume of snow, where T is measured in hours since midnight. Midnight is time 0. And I think there's supposed to be no snow. Janet starts removing snow. Accumulates is added. Removing snow at 6 a.m. The rate G in cubic feet per hour at which Janet removes snow is this. So this is the outgoing rate, the leaving rate. Now, it sounds like snow is still falling. No, midnight to 9 a.m. She starts removing it at 6 a.m. So it's still falling from 6 to 9. And then, I don't know. And this only goes up to 9 a.m. So snow is falling the whole time. Snow is falling while she's not removing. And then she starts removing it. So this is a rate model. How many cubic? We could write the rate model. The rate model sort of depends on the time you're at. The amount of snow equals the initial amount, which is 0, plus the amount that's accumulated, midnight, 0 to whatever time, ft dt, minus the removal rate. But she doesn't start removing it till 6. So if we're going to plug anything before 6, we're not going to use this part. gt dt, which is a piecewise function change. So this is kind of roughly our rate model. So part A says, how many cubic feet of snow have accumulated on the driveway by 6 a.m.? So that's just the entering rate, 0 to 6 of ft dt. And this right here is worth points for sure. The point breakdown here, out of 9 points, you get 2 points for part A, 1 point for part B, 3 points for part C, and 3 points for part D. Okay. And right here, this is for sure a point out of the 2 points for part A, the setup. And if you don't show it, even if you get the right answer, you lose it. So let's do what I've been doing. I'm going to go to Y. Now I'm probably just going to put the 7x e to the cosine x is in the exponent. So I put that in there. Make sure you're in radian mode. By the way, if you were trying to integrate this by hand, you can't. You just can't do it. So your calculator can, because it doesn't use rules. It does estimations. Okay, so we're going to go back to the home screen. Math 9, vars, y vars function y1, comma x, comma 0, comma 6. You guys should be getting fast at this. Typing these in. 142.2746889. I'm just going to write that all down just so I don't have to redo it later. So 140, do they say anything about round to the nearest like cubic foot or something? How many cubic? It says how many cubic feet, but it doesn't say nearest cubic feet. So I think we're going to do 142.274 or 5 cubic feet, right? Feet cubed or cubic feet of snow has accumulated on the driveway by 6 a.m. Okay. Part B, find the rate of change of the volume of snow on the driveway at 8 a.m. So they're saying find the derivative of the amount of snow. So that's A prime, very typical question on rate models. Find the rate of change of the stuff. And that's derivative of your rate model, which is going to equal your entering rate minus your leaving rate, which should kind of make sense. I mean, you could do the work right here, fundamental thermodynamics part 2, but it should make sense that the overall rate is going to be the entering rate minus the leaving rate. So I'm just writing that down, and then we're going to plug in 8 a.m., which is time 8. And so it's going to be F8 minus G8. I would write all this down, show what your calculations are. And so on your graphing calculator, you could go to the table and get the F8 is 48.4170322, and G8, if you look up here, is just 108. It's a constant from time 7 to time 9. And so then we could go back to the home screen and say 48.4170322 minus 108 equals negative 59.582967.8. And so we did our calculation. Now we need a, I don't know. Usually they say, all right, and describe it in the context of the problem. So usually, I mean, this you could just say the rate is negative 59.582 or 3 cubic feet per hour. We could just say that, or we could describe in the context problem. We could say the volume of the snow on the driveway at 8 a.m. You want to mention the time is decreasing at a rate of, and then don't put the negative, 59.582 cubic feet per hour. So that's a good description of the answer in the context of the problem with the correct units, mentioning the time, which is typical. I would say that's usually more typical that they'd ask you to do that. I don't think they asked you to this time. It was with 1 point for the answer. Okay, part C. Let HT represent the total amount of snow. So I've been using A, but they're saying use H. Well, I'm going to go and use H. Total amount of snow in cubic feet that Janet has removed from the driveway. Okay, so H is just how much she's removed from the driveway at time t equals after 9. Express H as a piecewise defined function with a domain 0 to 9. So this is just what she's removed. And so how much she's removed at time 0 is 0. That's our initial condition. So, and we could break this down. We could say, well, the amount she's removed is going to be the amount she had removed before plus, and we're not going to put negative for this because it's the amount that she's moved. I think I'm going to have to bail on this pretty soon, so I'm going to see if we can finish this as quick as I can. All right. 0 to t of gt dt. And so that's going to equal 0 plus 0 to t of, now from 0 to 6 a.m., she's not removing anything. So it's just 0 from 0 to 6 and not including 6. And then it's still 0 from 6 to t. It's 125 dt. And so we actually can integrate this. So I think we got to integrate it. 125 t, 6 to t equals 125 t minus 600. We could just say that. And that's from 6 to 7. And then so h of t equals the amount of h6 plus the integral 6 to t of gt dt, and then starting at time 7, we got to start with, well, how much was removed at time 7, and go 7 to t gt dt equals